Alright, hi everybody, this is the Math 31 optimization review. This is question 15. And this is actually, in some ways, kind of the exact opposite of the previous question. What dimensions are required for a cylindrical juice can with a volume of 500 mils if the amount of sheet metal used to make the can is a minimum? Basically what we're doing here is, this time we're given the volume and now we're being asked to minimize surface area. The previous question was doing the exact opposite. But here again we've got our can, R and H. This time we know that the volume of the can is pi r squared H. And what we're trying to do here is, we want to, oh sorry, not volume, we know the volume. What we want to do here is the surface area. We want to minimize the surface area. And surface area will be 2 pi r squared plus 2 pi r H. Okay? Now, in this case, as with the previous one though, what we might want to do here is take our volume expression here and solve for H. If we solve for R, we might get a square root in there. This is kind of awkward and I don't really want that. So if we solve for H here, we'll get 500 over pi r squared is equal to H. That's okay. And now we come back over to our surface area and we get 2 pi r squared plus 2 pi r 500 over pi r squared. So simplify that, 2 pi r squared plus, okay, well the pi and the r cancels and I'm left with 1,000 over r. And so there's our surface area. Now if we take the derivative, this is actually a really nice derivative because this will end up being 4 pi r minus 1,000 over r squared. Okay. Set that equal to 0. And now I'm going to solve for r, so 4 pi r is equal to 1,000 over r squared. Okay. Solve for r, and I'm going to get 4 pi r cubed is equal to 1,000. And so I'll divide, and I'll do that up here. So r cubed is equal to 1,000 over 4 pi. So r is equal to, now when I take the cube root of this, I'm only going to get one value here, one real value, and that'll be 10 over the cube root of 4 pi. Okay? So that is going to be the radius, okay, that makes this happen. If that's the radius, I can come back over here and to figure out what h is. But you know what? In a case like this, it probably makes a little bit more sense for us to actually get the decimal equivalent of this. So this will be 10 divided by the cube root. Oh, I don't know why my calculator is having issues with this. The cube root of 4 pi. Okay, so we'll get 4.3. And if that's r, we can get h by simply doing 500 divided by pi r squared. Okay, we already know what r is. Pi r squared, yeah. And so h is going to be approximately 8.6. Okay, now our surface area, the minimum surface area, I'm just going to simply come over here to this expression that is surface area in terms of just r, because I already know what r is. Okay? And what I'll do here is it'll make this 2 pi r squared plus 1,000 divided by r. And we get that our surface area will be 348.7 centimeters squared. Whoops, you're seeing an old question peek through.